In this video, we're going to be taking a look at transformations. So let's go ahead and take a look at transformations, and we're going to start with this graph y equals x squared. What a transformation is something that you can do to a basic function family, which in this case would be the squared family, or y equals x squared is the basic graph of it, and you do things to that function and it moves it around. So we're going to take a look at what if we took this x squared and we just added something on the end. We'll start there. So know that this has a plus k here. One nice thing about Desmos is I can do plus k, and then I can have what's called a slider. And I have it set to start at 0 right now. If I were to plug a 0 right in here, I would just have x squared. So what you see over here in blue is x squared. Notice this is red here. When the k starts moving, you'll still see a red graph in the same location that we see the blue graph right here. And that will be the basic graph that we're looking at. So let's let k change values, which means we're going to be adding a number onto the end of x squared. And let's see what happens to this graph. Watch the blue as k ends up moving around. So I'm going to go ahead and click this, and it's getting bigger, and notice it's moving up. And watch, I just stopped it at 5.9. That means that what we see in blue way up here is f of x equals x squared plus 5.9. Notice that your red graph is the original one, and it changed from being at 0 up to being at 5.9. Now let me play it and let's watch what happens. It's going to go down, and I'm just going to randomly stop it. Now I'm stopping it at negative 5.93. Notice what happened is this graph has moved down to negative 5.93 right down here instead of being at 0 where we started up here. So it looks like what happens when you have a k out here is that whatever k is moves the graph up or down on your y-axis there. Let's see what happens if instead of having a k there, I change this so that there is a plus h in here. So notice that rather than adding something on the outside, I have added something in the inside. That's having something in here and you square afterwards. I'm going to make a slider for h. Now, I'm going to move h back to 0. I'm also going to move k back to 0 because we want to look at just what happens with h for a moment. If I can get it there. Let me move h to 0. Notice the blue graph is now on top of the red graph again. I'm going to now just move h around. So k, which was outside here, moved the graph up and down. Let's look and see what h does. So I'm going to play h, and notice, oh my goodness, we're going left and we're going right, and it's changing. Now I'm going to stop it for a minute. Notice I stopped it, and it's over here at probably 3.32. If I were to click on here, I could click on this, and yeah, it's over at 3.32. Notice that our h is a negative 3.32. One nice thing that I like to think about is if I took this negative 3.32 and I added it to where I am right here at 3.32, I would get 0. Our h in this equation is a negative 3.32. That is the equivalent of having f of x equaling x minus 3.32 squared. If I were to plug this x coordinate where our vertex, the bottom of our graph, moved to, into this equation right here, I would get 0. Now, when you have things inside the function, like the h's, it's always kind of doing the opposite of what you think is going to happen. So a minus, you would think, should move it way over here, but it didn't. it moved it the other direction. So one nice way to think about where is it supposed to move to, it's going to move it to whatever would make this part right here 0. So since that's a minus 3.32, it moves it to a positive 3.32 because that's what you would plug into that parentheses to make that 0. So now what if I went over here and I drug my slider so I had a positive value? Let's stop it at, say, positive 4. I stopped it at positive 4, which means now I have the function f of x equals x plus 4 squared, because the h right here is a 4. Notice that the vertex right here, if I go ahead and click on this dot, it's now at negative 4. If we were to take and, whoops, didn't mean to do that. Take and plug this negative 4 into there, notice this expression would be 0. So that's where that moves the vertex to. So when you have something on the inside here being added, that's going to move it left or right. If it's a positive number in there, so it's x plus that number, it's going to move it to the left because the numbers on the left, when you plug them in, would make a 0 there. If it's a negative number, so like x minus 3, it's going to move it to the right because a positive 3 would end up making that 0 in there. If you have a number added on to the end here, that's going to do exactly what you would think it would do, and it's either going to move it up or down, whatever that value is. Now, let me clear all this out, and let's go ahead and set our h back at 0 again, and let's watch what happens if I play both the h and the k. So I'm going to start the h, that's making it go left and right. Now watch the k moved. Now we're going up and down and left and right all at the same time. I'm going to go ahead and wait until I can see it, and then I'm going to pause one and pause the other. And notice, let's let that go a little farther. And how about if we make this go to a nice neat number, if I can get it to stop at 6. Notice I stopped right here with the blue here. The h is 6 and the k is 2. If I plug 6 in here and 2 in there, that is the equivalent of having the function f of x equals x plus 6 squared plus 2. This here should have made us go left 6, and if you look at it from right here, we went left 6 to negative 6 right here, and then this right here should make us go up 2. And notice if we go up 2, we're right here, and that point that used to be at 0, 0 is now up here at negative 6, 2. So it's gone left 6 and up 2. That, no matter what the function is what's going to end up happening. So I'm going to clear these drawings and show you that real quick. Let's say rather than a squared here, I have a cube. So I'm going to make that a 3. Now look at the shape. If I go to this and I change it to a cube also, I still have shifted over from 0, 0 here, left 6, and up 2, I just have a different shape. So no matter what shape you have, that's what's going to happen. Now, we have the h and the k there. We could also have things that are multiplied. So I'm going to go ahead and cancel these out. And we're going to look